So today we are going to cover section 3.2. This covers parallel lines and transversals. This is a continuation from 3.1. So 3.1 we talked about corresponding angles. So you should already know that 1 and 5, 2 and 6, 3 and 7, 4 and 8 are corresponding angles. Well, we're going to cover the new theorem, the corresponding angles theorem, that tells us that if we have two parallel lines that are cut by a transversal, then the pairs of corresponding angles are congruent. So that means 1 would be congruent to 5, 2 would be congruent to 6, 3 would be congruent to 7, and 4 would be congruent to 8. The alternate interior angles theorem says that if we have two parallel lines that are cut by a transversal, then the pairs of alternate interior angles would also be congruent. Our alternate interior angles would be 3 and 6 and 4 and 5 in this graphic. We also have a theorem for alternate exterior angles. And if we have two parallel lines that are cut by a transversal, then the alternate exterior angles are also congruent. So that means 1 would be congruent to 8 and 2 would be congruent to 7. Now, these only work when we have two parallel lines. So in 3.1 we were simply talking about two sets of lines that were cut by a transversal. There wasn't anything special about the lines, so we didn't talk about angle measures, nothing. We just talked about relationships. But now we're going to take it one step further, and as long as these lines are parallel, we know that these angles are congruent. Now, what about the consecutive interior and exterior angles? We have theorems for those as well. Consecutive interior angles are going to be supplementary when we have parallel lines cut by a transversal. So that means 3 and 5 would add up to equal 180 degrees, and that the measure of angle 4 and 6 would also add together to give us 180 degrees. Moving on to consecutive exterior angles. Consecutive exterior angles are also supplementary. So the measure of angle 1 plus the measure of angle 7 would equal 180 degrees. And then the measure of angle 2 plus the measure of angle 8 would equal 180 degrees. So let's look at an example. If we have this graphic, we're going to use these theorems and figure out what is the measure of angle 2, 3, 4, 5, 6, 7, and 8, simply from our theorems and the little bit of information we are given. So we're told that the measure of angle 1 is 95 degrees. From that, I hope you would be able to gather that angle 4, 5, and 8 will also be 95 degrees. So angle 1 and angle 4 are vertical angles. This comes from chapters 1 and 2. We should already know this information. 4 is alternate interior to angle 5. And we know alternate interior angles are congruent. Another way you could look at it is 1 and 5 are corresponding angles. So that would also make them congruent. Lastly, looking at angle 8 is vertical to angle 5, corresponding to angle 4, and alternate exterior to angle 1. So, angles 1, 4, 5, and 8 are all going to equal 95 degrees. But how do I find the measure of angles 2, 3, 6, and 7? Well, let's look here. Angles 1 and 2 are what we call adjacent, but they are adjacent and something else because they together form this line. Hopefully, you are thinking that they are adjacent and supplementary. That means that we can subtract 95 degrees from 180, and that'll give us the measure of angle 2. So 180 minus 95 is 85 degrees. Now, similar thought process. I can get 3 from 2 because it's vertical. I can get 6 from 2 because they're corresponding. And lastly, 7 and 2 are alternate exterior angles. So, now I know the measures of all my angles. Let's look at some more examples. Okay, so the following examples, I want you to find the measure of the numbered angle or the variable and tell which theorem you used on each problem. Some of these, you can use multiple theorems on every problem. So you might not necessarily be wrong if your neighbor got something else, okay? So let's look at this one. Let's look. We are given that the measure of this angle is 102 degrees. What does that tell us about angle 1? Well, these two angles are vertical angles. So the vertical angles theorem tells us that vertical angles are congruent. So that means the measure of angle 1 is 102 degrees. Now, we just learned something new about angles 1 and 2. These are consecutive interior angles. And consecutive interior angles are supplementary. So, what plus 102 degrees gives you 180 degrees? You should get 78. Let's look at number 2. Okay, number 2, we're given that this angle is 130 degrees, and we're asked to find the measure of angle 1 and the measure of angle 2. Let's start with the measure of angle 1. So, the measure of angle 1 and our 130 degrees are consecutive interior angles. That means they're supplementary, so we would subtract the 130 from 180, and we should get that the measure of angle 1 is equal to 50 degrees. Now, there are a couple of different ways that we can find the measure of angle 2. We can find the measure of angle 2 by saying that angle 2 and the 130 degrees are a linear pair, or angle 1 is alternate interior to angle 2. Either one would be correct. I'm going to use the linear pair postulate. The linear pair postulate says that a linear pair is supplementary. Since the 130 and angle 2 are a linear pair, I can subtract 130 from 180, and I'll get that the measure of angle 2 is 50 degrees. Okay, so on the next few problems, I want you to pause this video and work them out. You're going to be working out number 3, number 4, and number 5. As you work these out, I want you to find the measure of the angles and the theorem that you are using to solve, or the reason that you were able to solve and find that value. Once you have that information, go on back to the Google Classroom, and in the classwork tab, I have a quiz kind of set up for you. That way you can enter what you get for the measure of the angles and your reason. The way this quiz is set up is it is like an essay form. So like on line 1, you're going to type in, let's say we're looking at number 5. So on the very first line of your thing, you would put x equals what number you get, comma, and your reason. Enter, so you go to the next line, y equals number, comma, and your reason. On these problems where you're finding the measure of angle 1, the measure of angle 2, and the measure of angle 3 and 4, you can simply put 1 equals if you do not want to type out the measure of angle 1. Just make sure it's pretty explicit and we can't make any, and I can't confuse anything. So go ahead and pause this video and do that. Go on, pause it. Okay, so hopefully you've already done examples 3, 4, and 5, and you have turned that in so I can see how we're doing. Let's look at this example, example 6. We're going to take this piece by piece, and don't try to get overwhelmed. So, example A says, if AB is parallel to CD. So we have AB and CD, and we're going to say that they are parallel. Okay. We want to look at angle BAC. So this is angle BAC. So that means this is most likely our transversal. So if the measure of angle ACD is 38 degrees, what is the measure of angle BAC? This angle. Well, hopefully you can see that these are alternate interior angles. Alternate interior angles are congruent, so the measure of angle BAC would be 38 degrees as well. Let's look at B. This time, we're going to have BC parallel to AD. And we're looking at angle BCD, which is this angle here. And angle ADC, which is this one, is 108 degrees. So, what kind of angles are these? Hopefully you're thinking that these are consecutive interior angles. And consecutive interior angles are supplementary. So if we take 180 degrees and subtract 108 degrees, hopefully you will find that the measure of angle BCD is 72 degrees. So let's look at the last one. We have AB parallel to CD, and it asks us to name two pairs of supplementary angles. Well, we technically have three different transversals here. So let's look at two different ones. let's look at this transversal versus this transversal. So angle 1 would be supplementary to angle 2. And then angle 3 would be supplementary to angle 4. So I write an equation showing that angle ABC is supplementary to angle BCD, and that angle BAD is supplementary to angle ADC. Let's look at a little bit of an easier example. So, we have a pilot up in a plane, and it sees a car on the ground at a 39-degree angle of depression. So, angle of depression is when we look down from a line of sight, and angle of elevation is when we look up. So, if the pilot is looking down, that means that this is his angle here, angle 1, and that is 39 degrees. The question asks us, what is the measure of angle 2 here? Hopefully, you're thinking that it is equal to 39 degrees because these are alternate interior angles. And the last example for today. We have a sidewalk that goes through our park. And we have that the measure of angle 1 is 52 degrees. And we're asked to find the measure of angle 2. Since our park is perfectly a rectangle, that means that these two lines are parallel. And since this is perfectly a rectangle, our two lines up top and bottom would be parallel, and we would have the edge of the sidewalk as our transversal. These are consecutive interior angles, so that means they're supplementary. And when we subtract 52 from 180, we get 128. Okay, if you have any questions about today's lesson, you can send me a message via Remind. You can ask it within Google Classroom on the video. You can comment, or you can wait until tribe time when I get back, and I'm more than willing to answer your question. So go ahead and start working on the very back side of the notes. That is your classwork. It's just extra practice to make sure you understand what's going on. And then the homework for tonight is the 3.2 bookwork. This will be due on Wednesday, the 20th. I hope this went over well, and just let me know if you have any questions.